Okay, we're going to focus on our f of x being a sine function. All right, let's look at a vertical stretch. So I've let a equal 2 here in this function. A equals 2. Do you notice that my function now goes from 0 to 2 instead of 0 to 1? So this number right here, like let's look at 3. Okay, now I'm going from 0 to 3. This number right here tells me how far it is from the center point vertically, so from the top to the bottom, divided by 2, split equally, will give us that a value. So if I were looking at a function, I could determine what my a is by looking at the difference between my minimum and my maximum on my amplitude. Woo, like that on the wave. What's the minimum to the maximum divided by 2? It's going to give me that a, the amplitude. I'm going to put that back, and I'm going to hide that one. Okay. Now let's look at this one. Here I've got b of x. All right. Well, when b is 1, has anything changed? No. But let's go here between 0 and 1. Now, let's look at the beginning of this period to the end of this period. Let's put a point right there. Okay, this is the end of our parent function's period, 2 pi. Now let's look at the green one, which is our transformed function. He has to come all the way over here to 4 pi. So do you think there's a relationship there? Well, yes. 2 pi divided by 2 pi divided by 1/2 is 4 pi. So you have sort of an inverse relationship there. So if I were to go to, like, let's say 2, now I still have my initial function ending here at 2 pi. I don't need that one anymore. So my original function going to 2 pi, and my transformed function now is half of that, just 1 pi. So if I take 2 pi and I divide it by my period, divide it by my horizontal stretch compression here of 2, I get 1 pi. So 2 pi divided by b gives us our period. Okay. I think that this one here is the easiest of all of them to see. So we're going to put that on there. Now, vertical shifts. What's it doing? Is any shape changing? Nope. I'm just moving up and down. All right, I can handle that. So I like to find my midline when I'm looking at a trig function. So let's say it's here. Shift left to right a little so we can see. I'm going from -1 up to 3, so my midline must be at 2. That means that my vertical shift is 2. Let's do the same thing. Let's move it down. Something like that. Okay, I'm going from -2 down to -4. The midpoint of that would be -3. Okay, that means that my midline is at -3, which means my vertical shift is a -3. It's a shift down of 3. Hide that one. One more here to look at. We're going to look at horizontal shifts. We're going to spend a little bit more time talking about horizontal shifts when we look at phase transformations, but this one is done on, I counted this on a value of pi here. We've got a pi step going on. So if I go pi up, right, if I'm adding pi as d, then I'm subtracting, or I'm moving to the left, pi on my graph. So going back to no change at all, I'm going to make this guy a different color. We're going to make him color and dashed so we can see the difference. Now there's 0. Now if I move it up, this guy moves left. Sometimes it's kind of hard to see which way left and right is because it's a period, so it's hard to see which way it's going. So let's put it back, and we're going to add a point here. There we go. And now we're going to, that point is now there. I'm sorry, that point is now here. There it is. Oop, get rid of him. One more time. Oop, moved over a little further. And then moved over a little further. Back on top of it. If I go 2 whole pies, then I'm just going to reline up with where I was initially. So you can see it as a shift 1 pie there, back on top, shift 1 pie there, and then back on top. We're going to do a problem here in a minute. I'm going to leave it for you guys to look at. So I want you to pretend like you can't see this over here. Okay, I'm going to hide the list. Whoop, whoop. There we go. So if I were looking at this purple line right here, comparing it to this one, this is my parent, can you identify all of the different transformations that happen on this graph? Let's look at the maximum, let's look at the minimum, let's look at the midline, maybe the difference between them, how far is it between the y values, how far is it between the x values. Okay, if I'm looking at one period, how far does it take to go one period? So those are all the different things you're going to want to look at when you look at a trig function that's graphed and you're trying to figure out an equation from it. So see if you can do that. That'll be your practice for this question.